Hello everyone. In this mini-series I will show how to work with time series data generated by a simulated device sent to AWS and saved into purpose-built TimeStream database. This diagram represents the solution that we are going to build throughout the series. We will use some simulated sensor that is connected to a device. That device sends data to AWS IoT core, where we utilize rule engine with respective actions to store data into TimeStream database and to log any potential issues with the CloudWatch logs. So this is the end-to-end solution. Within this first video, we will focus on establishing the CDK, which stands from Cloud Development Kit, on your local machine and deploying the TimeStream database. As I mentioned at the beginning, TimeStream is purpose-built time series database offered by AWS. Time series data is essentially a sequence of data points recorded over time. So in our case, that might be just temperature readings recorded by this sensor over the time and sent by this device to our cloud. Let's get started and set up the lab environment. This is a quick start. Let's go through it together. First of all, we create the virtual environment. Once our virtual environment is created, we can activate it, upgrade pip, because we will use Python to manage AWS infrastructure. That's why we need to upgrade pip and we want to install required Python packages. Okay, before deploying our application, let's check the source code. This is the overall structure of our app. app.py, this is the main file that consists all of the stacks that we are going to deploy. We use only one stack, which is the TimeStream lab stack, and if you go inside that stack, you can see that we create a TimeStream database, we call it test database, then we create a TimeStream table within this database called test table, and we adjust the data retention. That means how long we want data to be stored within that database before it gets deleted by AWS. Since this is lab setup, we are using minimal retention, which is 1 hour for memory store and 1 day for magnetic store. Finally, we create the dependency between the TimeStream table and the TimeStream database. Okay, so that's all for now. Let's go back to our quick start and deploy this infrastructure. Important note, in my case, I specify the profile. If you installed AWS CLI with default settings, you don't have to do that because AWS CLI created the default profile for you, though I prefer to use named profiles. That's a bit more advanced topic. We won't go into details. So in your case, probably it is sufficient to use CDK, deploy all. As you can see, we successfully deployed our TimeStream database using AWS CDK for Python. Let's switch to the AWS console to confirm that our resources are actually deployed. I'm logged into my AWS account, search for TimeStream. This is Amazon TimeStream, it's what we are looking for. This is our test database. We can go to our CDK and confirm that that's actually the name that we used for that particular database. If you go into that database, you can find tables and test table. Once again, this is the table that we created using the Python source code. So go to test table and you can confirm that the memory retention and magnetic retention is set to the values that we set within this configuration. This is minimal retention because we are just playing and testing. Go to actions, query table, and preview data. Execute this query. As you can see, no rows were returned because this is just an empty table. We can show a schema that got the measure name and time. So basically what we achieved is we created an empty database with a single table and there is no data in that table at this point. Going back to this diagram, we achieved only this part, but I think that's a great start. You've done it all using the infrastructure as code approach. So we use the AWS console only to verify if our resources were created, but we are not doing any manual operations from the web console, which is the suggested approach. Stay tuned for the next videos where we're going to create together the whole solution. All the best. I'm Łukasz Malinowski, the Internet of Things advisor and trainer.